Mathematics is all around us, shaping our daily experiences in ways we often overlook. When you're budgeting for groceries, you're using addition and subtraction to keep your spending in check. Ever noticed how recipes require precise measurements? That's fractions and ratios at work, ensuring your cake rises perfectly. Think about time management. Calculating how long tasks take or figuring out when to leave for school involves basic arithmetic and sometimes even algebra. And when you're planning a road trip, you're applying geometry to estimate distances and travel times. Even in sports, statistics play a crucial role. Analyzing player performance or calculating probabilities can make or break a game. So, the next time you think math is just for the classroom, remember, it's the invisible force that helps us navigate life efficiently and effectively. Embracing these concepts can empower you to make smarter decisions every day. Imagine a world where we can manipulate matter at the atomic level. That's the essence of nanotechnology, an incredible field that's revolutionizing everything from medicine to electronics. By harnessing the unique properties of materials at nanoscale, scientists are developing targeted drug delivery systems that can attack cancer cells without harming healthy tissue. Picture tiny robots navigating through our bloodstream, repairing damaged cells and tissues. In electronics, nanotechnology is paving the way for faster, smaller devices, making our gadgets more powerful than ever. Even in renewable energy, nanomaterials are enhancing solar panels, making them more efficient. This tiny science is not just a glimpse into the future, it's reshaping our present, proving that sometimes, the smallest things can make the biggest impact. GPS, or Global Positioning System, is a fascinating technology that relies on a network of satellites orbiting the Earth. There are at least 24 satellites in this system, constantly sending signals down to us. When you use a GPS device, it picks up signals from at least 4 of these satellites. By calculating the time it takes for each signal to reach your device, it can pinpoint your exact location through a process called trilateration. But it's not just about knowing where you are. GPS also provides information about speed and direction, which is crucial for navigation. The system works seamlessly, even in challenging environments like urban areas or forests, thanks to advanced algorithms that filter out errors caused by atmospheric conditions or obstacles. Interestingly, GPS is used in various applications beyond just driving directions. It plays a vital role in aviation, agriculture, and even disaster response. So, the next time you find your way using GPS, remember that you're tapping into a sophisticated network of satellites and technology that keeps our world connected and navigable. Black holes are one of the universe's most fascinating phenomena. Imagine a region in space where gravity is so strong that nothing, not even light, can escape its pull. This happens when a massive star exhausts its nuclear fuel and collapses under its own gravity. The boundary surrounding a black hole is called the event horizon, and crossing it means you can never return. There are different types of black holes: stellar black holes, formed from collapsing stars, supermassive black holes, which lurk at the centers of galaxies and can be millions to billions of times the mass of our Sun, and even intermediate black holes, whose origins are still a mystery. Interestingly, black holes can also emit radiation, known as Hawking radiation, named after the physicist Stephen Hawking. This radiation suggests that black holes can slowly evaporate over time. Studying black holes not only helps us understand the fabric of space and time, but also challenges our perceptions of reality. They are a reminder of how much we have yet to discover in our universe. What if I told you that the universe is filled with enigmas that remain unsolved? Take dark matter, for instance. It makes up about 27% of the universe, yet we can't see it or understand its true nature. Then there's the mystery of consciousness. How does the brain produce self-awareness? It's a puzzle that has baffled scientists for centuries. Consider the Voynich manuscript, an ancient text written in an unknown language, defying all attempts at translation. And what about the origin of life? We still don't know how simple molecules transformed into complex living organisms. Let's not forget the phenomenon of ball lightning, a rare and inexplicable occurrence that has left scientists scratching their heads. And then, there's the question of the missing antimatter. Where did it all go? These mysteries, along with the enigma of quantum entanglement and the true nature of time, remind us that the universe is a vast, uncharted territory, waiting for curious minds to explore its depths. Each question leads to more questions, and that's what makes science so thrilling. Today, let's dive into the exciting world of Python programming by writing your very first program. Python is known for its simplicity, making it perfect for beginners. To get started, open your Python environment and type print, "Hello, world." This simple line of code tells Python to display the text "Hello, world" on the screen. Why is this important? Well, it's a tradition in programming to start with this phrase, symbolizing your entry into coding. Once you run this code, you'll see the output, and that's your first taste of success. From here, you can explore variables, loops, and functions, building on this foundation. Remember, every expert was once a beginner, so embrace the learning process. Python is your gateway to endless possibilities in programming. Sleep is a fascinating process that plays a crucial role in our overall health. When we dream, our brains enter a unique state called REM, or rapid eye movement sleep. During this phase, our brain activity actually resembles that of being awake, which is why dreams can feel so vivid and real. Dreaming serves several purposes. It helps us process emotions, consolidate memories, and even problem solve. Some researchers believe that dreams allow us to rehearse scenarios, preparing us for real-life challenges. Interestingly, the content of our dreams can be influenced by our daily experiences and even our fears. Ever had a dream about falling? That's your brain's way of dealing with anxiety. So, next time you drift off, remember that your mind is hard at work, weaving together the threads of your thoughts, emotions, and experiences into a tapestry of dreams. Sleep isn't just a break from reality, it's a vital part of our mental and emotional well-being. Virtual reality is revolutionizing how we experience the digital world. Imagine stepping into a fully immersive environment where you can interact with 3D objects and explore virtual landscapes as if they were real. This technology uses advanced headsets and motion tracking to create a sense of presence, tricking your brain into believing you're somewhere else entirely. From gaming to education, VR is enhancing our experiences in ways we never thought possible. In training simulations, for instance, medical students can practice surgeries without any risk, while architects can walk clients through virtual buildings before they're even constructed. The future of VR is not just about entertainment, it's about creating new realities that can transform industries. As hardware becomes more accessible and software more sophisticated, we're on the brink of a new era where the line between the physical and digital worlds blurs. The potential is limitless, and it's an exciting time to be a part of this technological evolution. Memory is like a muscle. The more you train it, the stronger it gets. One effective technique is the method of loci, or the memory palace. Picture your home and assign information to different rooms. When you need to recall it, just walk through your palace in your mind. Another powerful tool is spaced repetition. Instead of cramming, review material at increasing intervals. This helps reinforce your memory over time. Chunking is also essential. Break down complex information into smaller, manageable pieces. For example, instead of trying to remember a long number, group it into sections. Lastly, don't underestimate the power of visualization. Create vivid mental images of what you're trying to remember. The more bizarre, the better. These techniques can transform your study sessions and boost your memory like never before.
Did you know you can multiply any two-digit number by 11 in seconds? Just take the two digits, add them together, and place the sum between them. For example, 34 times 11 becomes 3. 3 plus 4, 4, which is 374. Next, let's tackle squaring numbers that end in 5. Take any number, say 25. Multiply the first digit, 2, by the next higher number, 3, to get 6, and then append 25. So, 25 squared is 625. Now, for quick multiplication by 9, hold out your hands. 4 9 times 4, fold down your fourth finger. You'll see 3 fingers on the left and 6 on the right, giving you 36. Ever needed to divide by 5? Just multiply by 2 and move the decimal point one place to the left. So, 60 divided by 5 is 60 times 2, which is 120, and moving the decimal gives you 12. Finally, for percentages, remember that 10% is just a move of the decimal. So, for 15%, take 10% of the number and add half of that. It's a quick way to estimate without a calculator.
The Internet began as a military project in the 1960s, known as ARPANET, designed to connect computers for research purposes. By the 1970s, it evolved with the introduction of TCP/IP protocols, allowing different networks to communicate. Fast forward to the 1990s, the World Wide Web emerged, transforming the Internet into a user-friendly platform. This decade saw the birth of search engines like Yahoo and Google, making information accessible to everyone. The early 2000s brought social media, connecting people globally and changing how we interact. Today, the Internet is an integral part of our lives, influencing education, commerce, and communication. It's fascinating to think how a simple network of computers has evolved into a vast digital universe that shapes our world. Quantum physics explores the fundamental nature of reality at the smallest scales. Imagine particles that can exist in multiple states at once, like a coin spinning in the air, neither heads nor tails until it lands. This is called superposition. Then there's entanglement, where two particles become linked, so that changing one instantly affects the other, no matter the distance. It's as if they're communicating faster than light. And let's not forget about the uncertainty principle, which tells us that we can never know both the position and momentum of a particle with absolute precision. The more accurately we measure one, the less we know about the other. This challenges our classical understanding of determinism and suggests that at the quantum level, randomness is a fundamental part of the universe. These concepts may seem strange, but they form the backbone of technologies like lasers and quantum computing, shaping our future in ways we're just beginning to understand. Quantum physics isn't just a theory, it's a fascinating glimpse into the very fabric of reality. Have you ever wondered how sharp your mind really is? Let's dive into some mind-bending brain teasers that will challenge your IQ and keep you on your toes. First up, imagine you have a 3-gallon jug and a 5-gallon jug. How can you measure exactly 4 gallons of water? It's all about pouring and careful measuring. Next, consider this: a farmer has 17 sheep and all but 9 die. How many are left? It's a trick question, 9 sheep remain. Now, picture a room with no windows and only one door. Inside, there's a light bulb that can be turned on or off from the door. You can only enter the room once. How do you determine which switch controls the bulb? These puzzles not only test your logic, but also your creativity. So, gather your friends and see who can crack these brain teasers first. It's a fun way to sharpen your mind and maybe even learn something new. Optical illusions are fascinating because they reveal how our brains interpret visual information. When we look at an image, our eyes send signals to our brain, which then tries to make sense of what it sees. However, sometimes the brain gets tricked. For example, consider the famous Muller-Lyer illusion, where two lines of equal length appear different because of the arrows at their ends. This happens because our brain uses context and surrounding cues to judge size and distance. Another example is the checker shadow illusion, where two squares appear to be different colors due to the shadow cast by an object. Our brains compensate for lighting, leading us to perceive colors inaccurately. These illusions highlight the complex relationship between perception and reality, showing that what we see isn't always what is actually there. Understanding these tricks can enhance our critical thinking and appreciation for the intricacies of human perception. Solving a Rubik's Cube in under 2 minutes is all about mastering the right techniques. First, familiarize yourself with the basic notation: U for up, R for right, L for left, F for front, and B for back. Start by solving the white cross on the top face. Make sure the edge pieces match the center colors. Next, complete the white corners. Once the first layer is done, move to the middle layer by positioning the edge pieces correctly. Now, onto the yellow face. Use the FURUR algorithm to orient the yellow edges, then position the corners with the right algorithms. Finally, finish it off by permuting the corners and edges. Practice these algorithms until they're second nature, and watch your time drop. With dedication and a bit of speed, you'll be impressing your friends in no time.
Have you ever wondered why stars can't be green? It's a fun question. Stars are like giant balls of gas, mostly made of hydrogen and helium. When they burn, they create light through a process called nuclear fusion. The color of a star depends on how hot it is. Hotter stars shine blue or white, while cooler ones glow red or orange. But green? Well, it turns out that if a star were green, it would actually be so hot that it would look more like white. Our eyes just don't see the green light from stars because they mix all the colors together. So, even though we can't see a green star twinkling in the night sky, we can imagine it. Isn't it cool to think about how colors and temperatures work in space?
Building your own smartphone projector is a fun and rewarding DIY project. All you need is a cardboard box, a magnifying glass, and a few basic tools. Start by cutting a hole in one end of the box, just big enough for the lens of the magnifying glass to fit snugly. This will be your projector lens. Next, create a stand for your smartphone inside the box, ensuring its position directly behind the lens. Now, for the magic, the distance between your phone and the lens will determine the size of the image projected. Experiment with this distance to find the sweet spot for clarity and size. Once you've got everything set up, turn off the lights, play a video on your phone, and watch as it projects onto a wall or screen. This simple project not only enhances your movie nights but also sparks creativity and innovation. Plus, it's a great way to impress friends with your DIY skills.
Did you know that a star has a second life? After exhausting its nuclear fuel, a star doesn't just fade away, it transforms dramatically. Take our sun, for example. In about 5 billion years, it will swell into a red giant, engulfing the inner planets, including Earth. But that's just the beginning. Once it sheds its outer layers, it leaves behind a hot core, a white dwarf, which will slowly cool over billions of years. And then there are massive stars, which end their lives in spectacular supernova explosions. These cataclysmic events scatter elements across the universe, seeding new stars and planets. It's a cosmic recycling process. So, when you gaze at the night sky, remember, every twinkling star could be a remnant of a once mighty giant, shaping the universe in ways we're only beginning to understand. Isn't it fascinating how the life cycle of a star mirrors the cycles of life itself?
Imagine a universe that, after billions of years of expansion, begins to collapse back on itself. What would that look like? As galaxies draw closer, the cosmic fabric might warp, creating a kaleidoscope of swirling colors and gravitational waves. Stars would be pulled into a dance of destruction, their light bending and warping in a spectacular display. This scenario, often called the Big Crunch, suggests that all matter could eventually converge into a singularity, a point of infinite density. Time itself might behave strangely, stretching and contracting as we approach this cosmic endpoint. But what happens to the laws of physics? Would they hold, or would we witness a breakdown of our understanding? The very fabric of reality could unravel, leading to a new beginning, a rebirth of the universe, perhaps. The cycle of expansion and contraction might echo through eternity, reminding us that the cosmos is a grand, ever-evolving mystery.
Imagine a black hole, that enigmatic cosmic vacuum, hurtling through a wormhole, a theoretical shortcut through space-time. What happens next? Well, first, we need to consider the immense gravitational pull of the black hole. As it enters the wormhole, it could create a tidal force so powerful that it warps the very fabric of space-time around it. Now, if the wormhole is stable enough to withstand this gravitational onslaught, we might witness a fascinating phenomenon. The black hole could emerge on the other side, potentially in a distant part of the universe or even in another universe entirely. But here's the kicker: the intense gravitational forces could also lead to the wormhole collapsing, creating a cosmic disaster. And what about the information paradox? If matter from the black hole crosses through, does it retain its information, or is it lost forever? This scenario raises profound questions about the nature of reality itself. The intersection of black holes and wormholes could unlock secrets of the universe, challenging our understanding of physics as we know it. Isn't that mind-boggling?
Imagine a cosmic ballet, where two of the solar system's giants, Jupiter and Saturn, are on a collision course. Yes, you heard that right. These titans, separated by millions of kilometers, are drawn together by the gravitational dance of the cosmos. Jupiter, the gas giant with its swirling storms and iconic Great Red Spot, holds more than twice the mass of all the other planets combined. Saturn, with its breathtaking rings, is not just a pretty face, it's a powerhouse of moons and mysteries. As they approach each other, the gravitational forces at play could unleash cataclysmic events. Picture the violent upheaval of their atmospheres, the potential for new moons to form, or even the birth of a new celestial body from their collision. The energy released would be beyond our wildest imaginations, reshaping the very fabric of our solar system. This isn't just a distant possibility, it's a reminder of the dynamic and ever-changing nature of our universe. In the grand scheme of things, we are mere spectators to this cosmic drama, witnessing the potential birth of new worlds from the ashes of giants. The question remains, what will happen when these two colossal forces finally meet? The universe holds its breath.
Imagine a black hole, that cosmic vacuum cleaner, devouring everything in its path, and then on the other side a white hole, the theoretical opposite, spewing out matter and energy. What happens when these two titans collide? In theory, a black hole consumes everything, including light, while a white hole is like a cosmic fountain, refusing to let anything in. If a black hole were to encounter a white hole, it could create a fascinating cosmic tug-of-war. The black hole would try to pull the white hole into its event horizon, but the white hole would resist, pushing out matter and energy. This clash could lead to some wild phenomena, perhaps a burst of radiation or even a new type of singularity. It raises questions about the very fabric of space-time. Could this interaction create a bridge to another universe? Or would it simply lead to a cosmic stalemate? The mysteries of the universe never cease to amaze, and this hypothetical scenario is just one of the many wonders waiting to be explored.
Imagine a universe where we can travel faster than the speed of light. It sounds like science fiction, but let's explore the possibilities. According to Einstein's theory of relativity, nothing can exceed light's speed limit, yet concepts like wormholes and warp drives tantalize our imagination. What if we could bend space-time itself? Theoretical physicists are already investigating these ideas, suggesting that shortcuts through the cosmos might one day be within our grasp. Consider the implications: interstellar travel, contact with distant civilizations, and perhaps even time travel. The challenges are immense, but so are the rewards. Every great leap in science began as a dream, a spark of inspiration. So, let's keep pushing the boundaries of our understanding. The quest for knowledge is a journey worth taking, and who knows? One day, we might just find a way to outrun the light.
You know, time travel might not be as far-fetched as it sounds. Think about it. In the quantum world, particles are constantly popping in and out of existence. This phenomenon, known as quantum fluctuations, suggests that reality is a lot weirder than we perceive. Imagine if we could harness that. Some theories propose that these fluctuations could create tiny wormholes, potentially allowing us to jump through time. Sure, we're not strapping on DeLoreans just yet, but the idea that time isn't as linear as we think is fascinating. If particles can defy our understanding of time and space, who's to say we won't one day find a way to ride those fluctuations? It's a wild thought, but in the realm of quantum physics, anything is possible. So, while we may not have a time machine in our garage, the universe is hinting that time travel might just be a matter of perspective. Imagine a world where our thoughts and actions are influenced by the dance of positive and negative neurons, flickering in and out of existence. This theory suggests that these neurons could be gateways to understanding time travel. Picture this: every time a neuron fires, it creates a moment in time, a snapshot of reality. Now, what if some of these moments overlap, allowing us to experience time in a way we never thought possible? Scientists have already hinted at this phenomenon, claiming we've technically traveled through time, albeit by a millionth of a second. This fleeting glimpse into the past or future raises profound questions about our perception of time itself. Are we merely observers in a vast cosmic play, or do we hold the key to unlocking the mysteries of temporal travel? The implications are staggering, suggesting that every thought we have could ripple through time, connecting us to moments yet to come.
Oh my god, I'm coming!
Imagine a tunnel connecting two distant points in space-time, a shortcut through the cosmos. This is the essence of wormholes, theoretical passages that could allow us to traverse vast distances in an instant, or even leap through time. Picture this: you step into one end of a wormhole in the present and emerge at the other end, not just in another place, but in another era. The mathematics behind wormholes, rooted in Einstein's theory of general relativity, suggests they could exist, yet we've yet to find one. Some scientists speculate that if we could stabilize a wormhole, perhaps using exotic matter with negative energy density, we might unlock the secrets of time travel. But what would it mean to visit the past? Would we alter history, or create a branching timeline? The implications are mind-bending. As we explore the universe, the possibility of wormholes tantalizes our imagination, inviting us to ponder not just where we could go, but when. How far can space really go? It's a question that sparks the imagination. The observable universe stretches about 93 billion light-years across, but what lies beyond that? Some theories suggest it could be infinite, with galaxies continuing to drift apart due to dark energy. Picture this: if we could travel at the speed of light, it would still take us over 4 years to reach the nearest star, Proxima Centauri. Yet, the universe is expanding faster than we can comprehend, making it a moving target. And then there's the concept of multiverses. What if our universe is just one bubble in a vast cosmic foam? The more we learn, the more questions arise. Space is not just a void, it's a canvas of mysteries waiting to be explored. Imagine a universe where time flows backward, a realm where events unfold in reverse. Before the Big Bang, some theorists propose there existed a state of negative time, an intriguing concept that challenges our understanding of reality. In this pre-Big Bang scenario, the universe could have been a dense, chaotic mass, where time itself was inverted. Instead of moving from past to future, everything might have been collapsing into a singularity, creating a cosmic dance of particles and energy that defies our conventional notions of time. This idea opens up fascinating possibilities. Could our universe be just one of many, birthed from the collapse of a previous one? Or perhaps, in this negative time, the laws of physics as we know them break down, leading to entirely new forms of existence. The implications are staggering, suggesting that the cosmos is not just a linear progression but a complex tapestry woven through time, space, and beyond. It's a mind-bending thought that invites us to rethink our place in the universe and the very nature of time itself. Black holes and white holes are fascinating cosmic phenomena, but they operate on opposite principles. A black hole forms when a massive star collapses under its own gravity, creating a region in space where nothing can escape, not even light. This intense gravitational pull is why we can't see them directly. We only observe their effects on nearby stars and gas. In contrast, a white hole is a theoretical concept, essentially the opposite of a black hole. While black holes suck in matter, white holes are thought to expel it. They're like cosmic fountains, spewing out energy and matter, but they can't be observed in the same way because they exist only in the realm of theoretical physics. Interestingly, some scientists speculate that black holes could be gateways to white holes, suggesting a connection between the two. While black holes are well documented, white holes remain a tantalizing mystery, sparking debates about the nature of our universe and the laws of physics. Understanding these phenomena not only deepens our knowledge of space, but also challenges our perceptions of time and reality. Have you ever wondered why we can feel touch, yet on an atomic level, we can't actually touch anything? It all comes down to the way atoms interact. Everything around us is made up of atoms, and these atoms are mostly empty space. When you reach out to touch something, you're not actually making contact with its atoms. Instead, the electrons surrounding those atoms create a repulsive force that prevents you from passing through. Think of it like a game of tag where you can never really catch the other person because there's an invisible barrier. This is why we feel solid surfaces and textures. Our skin detects the pressure and vibrations caused by those repulsive forces, sending signals to our brain that we interpret as touch. So, while we can feel and interact with the world on a microscopic level, we're always just dancing around each other, never truly touching. Isn't that fascinating? Have you ever wondered how we can feel touch when, on a microscopic level, atoms never actually touch each other? It all comes down to the forces at play. Atoms are made up of a nucleus surrounded by electrons, and these electrons create an electric field. When you touch something, the electrons in your skin repel the electrons in the object. This repulsion is what you feel as touch. Think of it like a game of tag, where you can get close but never actually collide. This is because the forces between atoms are incredibly strong, keeping them at a distance. So, while we experience the sensation of touch, what's really happening is a dance of electric fields, not a physical collision. It's a fascinating reminder that our senses are interpreting complex interactions happening at a scale we can't see.